Yeah, it's a challenge, definitely.
Thanks, Steve,
Okay.
for that presentation.
Sure.
And I'm looking forward to observing some of those events. Next speaker is David Dunham. David is well known to most of us. He was the main force behind IOTA's founding back in about 1975. David received his PhD in celestial mechanics from Yale University in 1971. He played major roles in the trajectory design for NASA's International Sun-Earth Explorer mission, which was the first to map Earth's magnetic tail and also the first mission to visit a comet. He played a similar role in the NEAR mission to Eros. So he's been a professional orbit specialist. He will make 3 presentations today. The first is about near-Earth asteroid observations, both recently observed and upcoming. David, are you all set?
I think so.
Take it away.
Okay. Let's see now. Now I want to get rid of this thing up here. Let's see where. Hide meeting controls. Yeah, that's it. Okay. Okay. So let me go to slideshow. Come on. Okay. Can you hear me and see the title slide all right?
Just fine.
Okay. Actually, I should have taken out "and other" here because I'm just going to be concentrating in this presentation on near-Earth asteroid occultations. This is pared down quite a bit from an hour-long talk I gave last weekend to the Chesmont Astronomical Society in southeastern Pennsylvania. And I want to point out especially Fumi Yoshida, gave me a lot of their material. They've been doing amazing work with near-Earth asteroid occultations in Japan. So next, I also want to point out the very good article in the September issue of Sky and Telescope by Mark Bowie. Describes the motivation for and execution of the large occultation campaigns for exploring objects throughout the solar system, especially for the Trojan asteroids that are targets of NASA's Lucy mission. Anyway, just to get to the near-Earth asteroid occultations, the motivations for it, the dinosaurs died and now we rule, because dinosaurs didn't have a space program and they didn't know about planetary defense. So we can actually play a role in planetary defense with asteroid occultations. This is just an overview of IOTA, how we began and so forth. I won't go through all of this, but we're working with the NASA Small Bodies Node and the Minor Planet Center. IOTA archives all of our asteroidal occultation observations, as Dave Harold has described. And of course, the sizes, shapes, and accurate positions of several hundreds, maybe even a few thousand now asteroids have been determined. The interesting thing is that the first molestation asteroid occultation was actually for a near-Earth asteroid. It was the largest near-Earth asteroid, certainly by Eros, back in 1975. And this just shows the sky plane plot at the time, but we found there was one crucial observer who reported a miss where they were obviously looking at the wrong star. These are all visual observations, mostly with sky and telescopes. But I mentioned Brian O'Leary was the first where he actually made a coordinated effort to observe an event with mobile observers. They had about 6 or 7 teams of observers who went out with stopwatches and binoculars to observe this 4th magnitude star. But unfortunately, he didn't know about, we had been doing for 10 years before that, we've been doing grazing occultations, and we'd gotten the timing down pretty well with visual observations using tape recorders and WWV time signals. They had WWV time signals, but they didn't use tape recorders. So their timings were a little bit difficult because of the use of stopwatches. But anyway, it wasn't until 44 years later that we actually got the second observation of an occultation by a near-Earth asteroid, and there's strong emphasis to observe the asteroid Phaethon, which is the first ever asteroid that was actually discovered by a spacecraft, by the IRIS spacecraft in 1983, I believe, but it's now known to be a very active asteroid throwing off boulders like we've seen in Bennu from OSIRIS-REx, and it's obviously the source of the one of the most active meteor showers, the Geminids, and we're especially interested in it because Japan's Destiny Plus one spacecraft will launch next year and fly by Phaethon in 2025. So anyway, this shows this first effort to observe the occultation in July 29th, 4 years ago now almost. This just shows how we spread out over a large area with tried to fill 70 positions and had actually got observations from about 54 of them, and 6 of them that were positive shown with the fit here. But after that first success, then we were able to really nail down the orbit well, and just a few stations got the second event, and then just 1 or 2 stations got each of the other events going on through 2019 and up, and then 1 event in 2020. Next slide, this shows that first event showing all of the chords plotted on the sky plane, just to see the size of the effort, the kind of thing you have to do when you have very large uncertainties. In this case, the actual uncertainty in the path of the asteroid was much smaller than what we covered, because we were just afraid there might be some unknown errors in an object so small. And Dave Harold talked about how everyone found problems with all their software when they actually tried to analyze these observations. And it just shows the A2 term, how we were able to get an improvement by a factor of 3 and the determination of that from the observations of the occultations. The other interesting thing is that the mean orbit intersection distance, that's the distance of the orbit of Phaethon to that of the Earth, is actually decreasing, and it is actually going to go to 0 in about 200 years. But we know there is no risk of impact at that time, since the period of the orbit is now known well enough that the Earth and Phaethon will not arrive at the Moid point at the same time. But as time goes on, the error in the mean anomaly of the asteroid increases, or the small error of it magnifies by time to give a positional error that eventually goes all the way around the orbit. So you have to keep observing it in order to keep the orbit accurate. And in any case, we think there might be possibility of some change in the orbit due to this shedding of mass by the asteroid each time it comes near perihelion, because it's heated at perihelion, is close perihelion passage, only about 1/3 of the distance of Mercury to the sun. It receives about 250 times as much radiation from the sun as it does at aphelion. So that gives a short time period, very strong thermal shock that keeps pulverizing the surface, it seems. With the changes that might come from mass shedding, we don't know how strong the individual pulses might be. Anyway, to try to get a handle on this, and because it's the Destiny Plus is a Japanese mission, the Japanese Occultation Information Network has been especially interested in trying to observe these events, and they talk about their telescopes, their observation tools. I was sort of curious, we consider the WATEC cameras to be sort of the gold standard in IOTA for our observations, but they seem to have moved on to other cameras now in Japan, and this tells a little bit about it. And they're expanding. They're trying to set up an East Asia version of IOTA, and they're going to have a first meeting of that in late August, by Zoom. And they're trying to gather, English language version of their manuals talking about their techniques for observing, which would be of interest to us too. Let me go on to the next. It's already been, Dave Harold showed this, the best observed occultation by any near-Earth asteroid was one they did by Phaethon in 2021, October 3rd. And the prediction was very close to the observations were very close to the nominal prediction. Following the 2019 and 2020 observations. Then a year later, they observed another event quite well in Hokkaido, and you can see they got a pretty good handle on the shape. But here is the predicted point in the near the top of where they observed. So there was a shift to the south of the path of 2 to 3 kilometers. Causing misses at the southern, causing them to not cover the southernmost station because they had too much confidence in the orbit. We were wondering about that. So they asked, why did the zone shift? And Fumi wrote a slide about this, showing how the asteroid went through a parastron or perihelion passage in May of 2022, and that was between those two events. Could have been something at that perihelion, possibly a larger amount of material dislodged from the asteroid than usual and gave it an impulse that caused that shift. We'd really like to know. We need some more occultations to find out, because we haven't got any observations since 2022 October. I'll be going later on. I'll show there are several opportunities coming up that we should try to observe. Next, I'll talk quickly about Apophis. People know it's going to pass very close to the Earth in 2029, and be about 3rd magnitude. There's already the OSIRIS-REx spacecraft is going to be directed to encounter the asteroid after the flyby, and there's another possibility of missions that might fly by the asteroid before to try to characterize it, better than we can do even with occultations. Anyway. We know now that there was no impact when the asteroid was first discovered. There was a small possibility of an impact in 2029, but that was ruled out pretty quickly with subsequent observations. But showed that after this, though, these small errors in the orbit are magnified by this close approach to the Earth, causing later errors in the passages for following years, because it just went into another resonant orbit, and so there's a possibility of impacts in the later part of the century. Other close approaches. This shows some of those other close approaches, but showing how the initial is the dotted line was the initial prediction, but then after in 2021 it was narrowed down quite a bit, and the occultations and the radar observations from 2021 have done much better. This was this is an effort before the radar and the occultation observations of 2021. This just shows from the Planetary Defense Conference in 2021, I gave a talk about the Apophis occultations. This is the first observed event, how we recorded it with two of our mighty MIDI stations at 80 millimeter telescopes pre-pointed. You know, we set up 5 pre-pointed telescopes, but 2 of them actually got the occultation light curve here, and the others had misses, as did everyone else, except for Richard Nugent was between these 2, and he also got a nice positive. But then, you know, just looking at this, this shows the residuals of the observations, you know, relative to a fixed orbit, showing that the residuals are very small for the later events observed, but are quite large for this one. So we were puzzled about that, because 4 nights after March 7th, there was another occultation in Europe, and the prediction was updated to take that into account. People went from Thessaloniki, Greece, went to Mobile to observe it, and their 2 stations had no occultation. So after the Phaethon successes, we were very puzzled about that, but we found out the reason with the next deployment, where we had several stations with on March 22nd, 2021, and Roger saved the day by you know, setting up his 5 large telescopes along this highway in Florida. This just shows where the prediction was on the left, JPL 2007, but where it actually went with JPL 2014A. You know, and Roger has these great scopes that he set up on specially made low mounts, so he doesn't have to lift the telescopes up onto the high tripods that they make, and he's got very good at pre-pointing these things. This just shows Guy Kutross recording at high speed cadence of one of the Apophis occultations in New Mexico in April. So after he got this one, we knew that the JPL 214 one was the one to use, and it was that observation that allowed that determination. It just shows how occultations help retire the risk of Apophis for at least the next 100 years. This just shows how the errors, this small error here is a blow up, showing how by sea the radar observations came in, and that really retired the risk. But then the occultations and points D here you know, narrowed the errors even further. And that's shown by Damya Swami's talk that she gave at the ACM a few weeks ago, showing how there was almost an order of magnitude collapse in the future uncertainty in Apophis's orbit, from with everything up through radar showing in the top curve, and then with the occultations added, showing the errors, how they collapsed in the bottom curve, to say about an order of magnitude. And next slide, of course, we had Didymos, Dimorphos system, occulting the star, and Norm talked about this pretty well, so I'll you know, sort of go through this quickly. I just want to point out this very well observed event with a 9th magnitude star that occurred on January 21st, 2023, which is by far the best observed of the Phaethon events, because it had such a nice bright star and they got good signal to noise ratios. This shows the occultation by the asteroid and by Dimorphos recorded at one of the stations. Next slide, but we had other successes too. This high inclination threatening asteroid, Sisyphus, was, you know, there's not going to be any, there'll be at least 15 years before we'll get a chance to observe this asteroid again by radar. So we were hoping to get an occultation last year. We wanted to do a campaign, but this event occurred right at Thanksgiving and people didn't much want to travel then. But it happened to pass pretty close to Steve Messner's home. And so he went out and observed it from Minnesota. He just went to the predicted path. And sure enough, the prediction was more accurate than expected. So and he had a positive. So that really nailed the orbit for that one, just with a single observation. But you know, it's not always that you'll get only a 1/10 of a sigma shift, which is you know, that he had. So anyway, another near-Earth asteroid that we're interested in, it's not a threatening one, but it's a high flyby target of the Hayabusa 2 mission. So there have been large expeditions in Japan to try to observe this, and this shows the skyplane plot showing the observations. One observer finally in March got a positive, and this shows the light curve fitted to Peyote. Peyote was, you know, Anderson, you know, Bob Anderson changed the program to, you know, fit the Fresnel diffraction pattern to assuming a circular object, and it did a nice job of fitting the U-shaped bottom of the curve. Roger Venel gave a talk about Fresnel diffraction effects last year, and this gives some hint that the asteroids like Didymos don't have diffraction effects over most of their orbit, but Dimorphos, much smaller object, if it gets more than 2/10 of an AU away from the Earth, then it starts getting effects like this. And CC21 is a 600-meter diameter object, so it also gets effects, but not quite as strong. But of course, Apophis is in this range now, and Apophis has essentially gotten diffracted out now. Apophis is too far away and won't be close enough again to really get good occultations again with reasonable durations until a year or so, two before 2029 flyby. Finally, Norm talked about this effort for the occultation of this 8th magnitude star by Tantalus, our brightest near-Earth asteroid event this year, which we successfully observed near Socorro, New Mexico. And as you know, he described, you know, Ted Blank set up 5 stations and got data at 4 of them, and we set up 5 stations and we got data at all of our stations, but all of them had a miss. We had wanted to have this one station closer to the center than we positioned it, but there was no shoulder on the side of the road where we could pull off for a distance of about, you know, 200 meters or so. So we had to drive beyond where we wanted to be. Otherwise, we might have gotten a second chord on this. But also the asteroid was smaller than predicted. We found a report, a paper published just last year that said the radar determination of the diameter is 1.4 kilometers rather than the 2.1, which we were expecting. But it's, Norm fitted a slightly bigger curve that, but 1.4 would work. I think it's about right. Anyway, I'll just go through quickly the next events coming up. This just shows the near-Earth asteroid occultation prediction page that we have on the occultations.org website, showing events throughout North America to magnitude 12.0. And I highlight the Phaethon events here that are coming up. And we hope to observe ourselves the one on August 17th. We're actually going to be at a conference, the Astrodynamics Specialist Conference. I'll be giving a paper there on halo orbits for spacecraft on that week. So anyway, I hope the other people can cover these other events if it's weather permits. Next slide, this shows the more important NEA occultations in North America during the second half of the year, showing especially the Phaethon events and the 2001 CC21, the Japanese Hayabusa 2 target asteroid. We have a couple of those events that are pretty good, late in December. With my search, though, new search picked up another Phaethon occultation on September 25th that I didn't know about before, shown here. And the table below gives basic data about the information events. Let's see what. Oh, there was. Oh, I went backwards, I think. Okay. Besides one of the papers at the asteroids, comets, meteors meeting in Flagstaff a few weeks ago was this one by people at JPL and others about the hazardous kilometer size NEOs for the next 1,000 or 2,000 years or so, where they've figured out, during the next 1,000 years, these asteroids will have uncertainties in their mean anomaly that will accumulate, their error in the mean anomaly will accumulate multiplied times the number of revolutions, will eventually, during the next few or several hundred years, will make their uncertainty 180 degrees or more, so that they can be anywhere on its orbit. So these are the events they have identified as the most threatening that we should be trying to improve. So this was sort of a blueprint for us that we're going to try to concentrate on getting these events when we're not going after spacecraft mission targets. Especially we have a number of events with this 1950 DA. All of these are kilometer sized or a bit larger asteroids. Any one of them could cause quite a bit of trouble if it hit the Earth. Next slide, this shows a 1950 DA event on August 30th, passing over the southeastern US. But you see the error is quite wide in the orbit, but hopefully we'll get lucky and the real error will be quite a bit smaller than that. And so maybe a reasonable deployment might catch an event like this. Then it occults another star just a few days later over Florida, a nice bright star, an 8th magnitude star in this case. Another event, asteroid of interest, is 2005 UD, which has a Phaethon-like orbit. It's about a 1 kilometer asteroid, near-Earth asteroid, and the Destiny Plus spacecraft can, after it flies by Phaethon, can do an Earth flyby and can change its orbit and get to this asteroid. And so we're interested in, the Japanese are interested in occultations by this one too. And this shows one event that they found in October 27th. And another 50 DA event in November over Arizona this time. And a 2001 CC21, a Hayabusa 2 mission, a good event over the eastern US. And another one over the northern, I think Steve showed this one already. And now here are the best asteroid NEA Occultations of 2024. Steve has mentioned some of the individual events. Now, this just shows the big picture showing all of the good Phaethon events and the Didymos events. It's curious that the July 12th and the August 25th paths are almost on top of each other. But the one, the August 27th event, the low point, it's really going to be hard to observe from Florida because of low altitude, whereas the July 12th event will be better. It will be higher altitude, at least in southern Georgia. And this gives the basic information at the bottom about them. So this will be feeding into the RASC handbook for 2024. These are just the conclusions. The Bright 2019 event was the first successful campaign for a small NEAs, for a small one. And then, the radar size and shape were verified and improved the orbit tremendously. But then the recent observations show that there could be stronger than expected variations near perihelion. So we need more observations to try to follow this. And of course, the occultation technique was successfully applied to Apophis, which is 10 times smaller, further demonstrating the strong astrometric power. And of course, Didymos and Dimorphos have helped improve that. It's unfortunate we never have campaigns large enough to actually get Didymos before the Dimorphos impact. If we'd had a few occultations by Dimorphos before the last year, since September's impact, we could have really got a tremendously accurate measurement of the chain, force of that impact. Of course, it was quite good what we did get anyway. Anyway, the Hera mission is going on its way to, it's going to be going to Didymos pretty soon. So, of course, we keep observing those events. And I just have, I gave this for the other talks to indicate a website where I posted it. So that's all I have for this one. If there are any questions, I'll take them now before going on to the next one. We're a little behind. So,
David, on the December 30th CC21, the RUE had an entry, or there was an entry called Bad PM. That one goes right over Arizona, so I was curious about what that might mean.
oh, let's see. Reliability is good. Let's see, this is, wait, no, that's not the one. The CC21.
Yeah, if you look at page 26, it's got that list of and way at the bottom you see.
Oh, yeah. Bad proper motion. The RUWE was not determined because of bad proper motion solution for that star. That's unfortunately, we have that uncertainty for that event, but possibly by then, maybe there'll be some more Gaia data release for it, but we will, probably not by then. So we'll probably just have to live with it and take our chances. But the orbit for that is uncertain anyway, because that March 5th observation, we had great hopes in it, and we updated the orbit with it. But there were some big expeditions after that, including for a 5th magnitude star in Japan, where they had about over a dozen stations set up, and they all had misses. The problem was that March 5th star had an RUWE of 1.9 or something, so it was greater than the 1.4. And so it was clear that its position was, the star was in error, and that's thrown off our predictions for this event. We need to keep trying. We might need to rethink that orbit and just try to improve it with the best astrometry we can get. And perhaps by early December, we can get some astrometric observations of both the asteroid and the star from the 61-inch telescope at Flagstaff. I talked to Mark Morrison when we were in Flagstaff, and he said, yeah, it's a great telescope. It can get about milli-arc-second astrometry, relative astrometry, relative to the Gaia frame. So if we can do that with this asteroid and that star, maybe we can improve that prediction. So.
Thank you.
Okay. Close this one and I'll open. Next one is the special ones. So okay.